Coming up on this episode of the IoT Inc. Business Show.
And that's why everyone's excited about IoT right now. Everything's converging to a point where it's not the easiest thing to do in the world, but man, it's gotten a lot simpler than it was in 2012, 2013. And in 2012 and 13, if you were trying to do this in 2008 or 9, it was really difficult and really expensive.
It's a heck of a lot easier than it used to be, but most IoT projects still involve custom system integration. The question now is how much. Although the definition of an IoT platform or AEP is not always clear, what is clear is that a platform saves a lot of time and a lot of system integration work. There may be legitimate reasons to develop your own platform in-house, but by definition this means you're going to become a software company, big time. In this episode of the IoT Business Show, I speak with Bryan Kester to get his take on what an IoT platform is, the technologies involved, and a candid view on the strengths and weaknesses of IoT platforms today.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com.
With me today on episode 18 is Bryan Kester. Bryan is CEO of SeeControl, and he's responsible for its strategy and operations. His background is in sales, investing, and consulting, and he has over a decade experience in the Internet of Things and M2M markets. I first met Bryan at GoGoNet Live, where he presented on the build or buy decision for IoT platforms. He obviously had a lot of in-the-trench experience, so I wanted to get him on the show. Bryan, welcome.
Thanks, Bruce, for having me. I really appreciate it.
So I read in your bio that you have a BA in political economics. How exactly does that compute with IoT?
I have not gotten that question in quite some time. So at my school, there was a major called political economy that it sort of fused economics with business and a little bit of poli-sci. And you also had to be fluent in a language theoretically by the time you graduated. So it's a pretty intense major. I actually entered school as a computer scientist, and that program was really, really, really difficult to have any free time with. So I wanted something a little more lightweight and something a little more big picture focused and business oriented. So I did that, and then I got a minor in computer science, which I don't really advertise as much. But I've been working with computers since I was 7 years old. So that sort of fascination's been with me forever.
Yeah. And what was the language that you theoretically came out with?
Well, someone told me at some point that French was the second most widely spoken language in the world, or maybe it was the first at some point. So I took French and then realized it was completely useless. So I did get through. I did get through several semesters of it, and I was pretty good with it for a while. But then I made the mistake of taking German near the same time, and they're just completely opposite. So it messed up my ability to speak either one.
I don't know if I think I probably told you, but I lived in Montreal for 13 years.
Yes.
Both my kids are fluent in French, and I would argue that it is not a useless language. In fact, I always told my kids, learn the language where you want to go, because if you learn Russian, then most likely you're going to go to Russia. Not that there's anything wrong with Russia. If you learn German, you're going to go to Germany. If you learn Chinese, you're going to go to China. And I always love France. So I think, in their future, they'll probably, well, given my daughter's name is Paris, I think they'll probably be in France. But, in any case, I'm biased. Well, why don't we start? Tell me a little bit about yourself. I mean, you have a little bit, but a little bit more of your background in IoT.
Yeah, I have a hard time always counting this up, but I've actually been involved in 4 or 5 IoT, quote unquote, related companies.
Okay.
Mainly early on, I was an investor with a small venture capital firm here in Silicon Valley, and we put money into a couple different companies at the time. One was a company that did RFID way back when, which, by the way, people don't realize that the term IoT was actually invented by a gentleman at the MIT Automatic Identification Center, a gentleman by the name of Kevin Ashton, and it was the term Internet of Things was actually invented for RFID. It was the notion that you'd have a transponder of some sort on literally everything, even very, very low cost items.
Sure.
So anyway, I started off with RFID. That was a big hype wave, kind of a little bit like IoT is going through right now. But if you actually look at it, there's a pretty thriving, vibrant market out there for RFID systems once the kind of first wave of excitement died down. So it's a real business, real market. So I did RFID. The company was doing remote security, and then that sort of blended into doing a lot of different industrial products that managed the flow of materials in plants. Pressure sensing systems that were in plants. There was another company called Vistant I was at. Another company that did healthcare, pharmaceutical dispensing and vending machines called CareFusion, which is now part of Cardinal Health. And so throughout all those experiences, what I and a few folks that are still with me on our team learned is that we were, depending on which company we're at, we were generally trying to offer a end-to-end solution. So something that included a device or a machine, a connection in the middle, which it sometimes was cellular in a lot of cases with a cell phone plan, and then scalable software on the other end. And throughout all those different companies, which almost all of them were vertical, healthcare, logistics, industrial manufacturing, customers there was a complete void for kind of a thing management platform that people could subscribe to, where they could, easily talk to machines, make sense of their data, and then manage them in one place. So SeeControl is the culmination of essentially several companies that I and our team's been with, where we've done everything from literally hand building devices in prototype mode all the way out to production, to dealing with carriers for cell accounts, to building really scalable web software. So we've been around the block, and most of the folks in our company have been at the various machine-to-machine or IoT pioneers for several years. Companies like Atlantes, Exedia, Sierra Wireless, and the like.
Oh, okay, so I didn't realize that you have a team that's kind of been with you for a little while then. Yeah,
absolutely. Our CTO has been with me for 8 years. My number 2 person has been with me for 4. I have one person on our team. She's been with me for over a decade. Working with all kinds of different customers. So there's very little that we haven't seen, although given the things that are happening with IoT these days, there are some novel things that pop up every once in a while. But for the most part, we've seen literally everything in most verticals.
Been there, done that, have the scars, have the t-shirt.
That's right. Maybe a sweatshirt. It could be either a sweatshirt or a good fleece at this point.
A nice hoodie, maybe.
Yeah, exactly.
Now, how long have you been at SeeControl?
I've been doing SeeControl for 5 years. I actually did help the company. It's been around for a while. The company has been around for 10 years. It had a product that was originally in it was kind of a vending machine type product, where it was doing something very akin to what you see with the Amazon lockers that are out there, where you put inventory in those lockers and pull them out, and they're all managed over the web. So I helped the company get started as a consultant way back when in the market. And then it actually was really concentrated in the automotive sector. And 2008, 2009 were not very kind to automotive. So so we essentially rebooted the company around this new platform that I and the rest of the team decided to build.
Yeah, and it sounds like you had a lot of experience from different verticals in kind of what was needed out there.
That's right.
Yeah. So, all right. Well, that's what people know. What don't people know about you? What's something interesting that would be fun to hear about?
Oh, fun.
I don't know about fun, but
I guess the one thing I don't really advertise a lot, but getting back to sort of my college story and days, I was really serious about being a water polo player. for quite some time in my life. And I was on a track to do that at a pretty high level. But at the school that I was at, virtually half the national USA team was at my school. And,
what school was that?
University of California, Berkeley.
Okay. Berkeley, yeah.
And back in those days, every year they won the national championship. So I got in the water, and we've met. And I'm obviously a bigger guy. I was a lot of cases the smallest guy in the pool. So yeah, it's 6'8", guys that were very, very, very large. And not only were they
wingspans of 7 feet at least.
Yeah, incredible athletes. And then also when they weren't playing water polo, they would be actually competitive swimmers. So I kind of, between that and also trying to be in our computer science program, which was a full commitment at the time, I just threw up the white flag on water polo and decided to become a businessman.
And take French and German.
Exactly.
Yeah. All right. Well, let's dig into IoT, and in particular, what I want to talk about today is obviously your expertise, the IoT platform. But I think there's a little bit of confusion, at least maybe it's just from me, but I think there's a little bit of confusion in the market of what exactly what are the boundaries of an IoT platform. So maybe tell us, what are the components of an IoT platform, or I guess maybe some people refer to it as an application enablement platform, but what are the components? What are we looking at?
Yeah, I think the first thing to really recognize is that the confusion is somewhat valid and founded in the sense that these platforms have been around for a long time. One company that's in our space that's now been acquired by PTC, Exida, has been at it since the late 90s. True pioneers. And they've really focused on connectivity from the first day. Broadly across different types of machines and devices. But also generally what's been out in the market is that folks who manufacture gateways that help you get a machine on communicating with the internet have almost all offered their own platform of sorts for their products that would help you, manage that device. And so there's been a lot of quote unquote legacy platforms out there that are device specific, or in a couple minor cases have been horizontal. And so that's where people have gotten confused, is that the definition of a IoT platform really started in that world. But then it's just sort of grown up to start broadly encompassing everything. Because when you look at IoT, it really is about everything, like not just physically everything, but also about just about every facet of computing. You have a remote device that is some sort of remote computer that may be talking to some sensors that are plugged into it. And then either by itself or with the help of another device is getting information onto the internet. It might be doing analysis down there, that sort of local edge of the network level. And then you're another thing you have to worry about is how does the information get back to me? So that's some sort of network, whether it's a local Wi-Fi network, a RF radio network, like what's used a lot in utilities for talking to meters, or the cellular network, which obviously comes from a variety of cell carriers. So you have devices and you have communications. And then thirdly, because machines can send an absolutely unbelievable amount of data if you let them, we are talking about some of the biggest software, really known to man in the web application sphere. So if you take all three of those things together, that is a lot to deal with. So, if you take that context and you look at what an IoT platform is supposed to be, initially the definition was just to deal with connectivity and device management. How do we connect to the device, get the information off of it, and then get it into some central system somewhere? And that's where the term enablement came from, because essentially you get a device cloud of sorts, and you could plug that into your backbone infrastructure. But what people have come to realize is that that's not enough, or you just simply run out of budget before you can get to IT and get those devices plugged into the backbone infrastructure. And you really need to be able to see that information like online in real time as soon as you possibly can. So that all being said, the modern definition of an IoT platform, and some are focused on enablement still, where you get data into a central system, and then others are focused, like ours, on actual solution delivery, like putting a solution in someone's hands. So those components include the connectivity, of course. That usually means you're dealing with some sort of communications protocol that the device or remote machine is equipped to handle. And then on that remote device or machine, you've got something that we call a payload, which is really just the message that comes off the machine itself. And that message, tends to be in some sort of format like binary or text, or people may have heard of XML. And some other sort of things that really are more computer readable versus human readable. So that's the base part is connectivity and dealing with the message back and forth, as well as is the device, healthy? Is it online? Is it communicating? Does it have a problem? Do I need to return it to its manufacturer? So then you get into what we call message queuing, where the messages get into a big line and they ask to be either sent off to another system, or deposited into some central repository. So just think of a database. So sitting within that, you also a lot of times have what's called a streaming event processor, which is a lot to say, but it's basically just a way of describing logic that runs that looks at messages that come in and essentially tries to make sense out of them at some level. So you see 100 messages come by and you realize like, aha, that means the machine is on.
And this is all done. This is happening in line with
everything tends to happen at, those three components, the connectivity, the queuing, and the event processing tend to happen together.
Right.
So that's the basic platform definition that's been out there for a long time. So now what's been added in recent years is data storage itself. So being able to get the data into one place and just have it sit there. Prior to recent years, that the data used to just be trafficked off to other systems, as I mentioned before. Then you put an API on top of that data so that it's sitting there in a database, and now you can have an IT person go tap into it, or you can build an application on top of it. So that was kind of the next wave, was putting APIs around things, and that was really sort of Web 2.0 era. And then on top of that, you have people starting to offer, including us, various flavors of taking a look at the information and trying to make like deeper sense out of it. So at a basic level, virtually everybody has what's now known as a rules engine. And just think of it as kind of just doing simple checks on things. Is the temperature too high with this event versus the other event? Is this machine, is it online? Has it been online for a certain amount of time that makes sense for us? Sort of simple if-then type of statements. If this happens, then notify somebody, or if this happens, turn the machine off. So that's called a rules engine. Now, more recently, what's been added on top of those rules is a couple things. One's real analytics, so being able to look at data in real time, as well as both historically and figure out higher levels of information. When we talk about machines and things, that tends to be some sort of prediction, or what we also call a state modeling machine. So a prediction might be something where you have an analytical algorithm that looks at 100 different events that may be happening in real time, or in a combination of real time and then over some period of time. And then it just says, you know what, I think this machine's going to fail based on all the data that I'm seeing, and it's got a 70% likelihood. That would be analytics. Another type of analytics would be, say you have a year's worth of statistics on a machine. As a new data point comes in, you might calculate and update the new statistics. And if it's wildly off from what the last year's statistics were, you might add that to a new data reporting set that says outlier. And then you have a database of outliers, and then you can go analyze that. So we're starting to now get into the world of what people classically thought of as business intelligence. So that's a big piece that's been added recently, both within platforms themselves, or just as either other IoT platforms that can now plug in. Like there's companies that are springing up that do nothing but predictive analytics for IoT. And then the last piece that's really been missing, and this is where SeeControl is very focused, is delivering an application online without having to go build something from scratch. And that's where sort of the modern IoT platform is at now. It's a single experience where you can get your machines connected, analyze the data, and then deliver an application. And then ideally, like for example, in our world, it allows you to model the thing that you're managing itself and essentially virtualize your product and then attach data and devices to it. So that was a huge description, and I apologize for the length of that. But there's so much happening here that it's important to point out that there's a lot of pieces that if you attempt to go build this on your own, either you need to get really educated, which you can do with us. We can walk people through that whole process, and then make a decision if you want to go it alone. But so much of this has already been built up over the years. I mean, coming up on over a decade now, that it just doesn't make sense to go build something new from scratch unless there's a really strategic reason why you're doing that.
Okay. Well, let me sort of paraphrase it. So you have the connectivity and the payload and the message queuing, and I guess the messaging can go in both directions. Is that right?
That's right. You can do two-way communications.
Yeah. So this is more or less pulling the data off the sensor, and you're obviously not supplying the sensor itself, but you're connecting with the sensor with a protocol, using another one to encapsulate its payload, I should say, and then another one to basically queue the messages or basically organize the information as it's coming in. And you said that was kind of the line that was drawn. So in the past, you're saying the platform would pull the data and then just dump it into a database, or what was the delineation before, and then we'll get into the other parts.
Yeah. So traditionally, the data would just get trafficked out to some other system. So it would would essentially bounce through the IoT platform and then head out to, say, if you were a big customer at SAP, head out to an SAP database.
Okay. So then you're saying added data storage, and basically a way to access that data through the storage with another API. And then once you had that data, start doing stuff with it. And things you can do is use the rules engine again to just look for simple things, and then analytics from there. So the first part was all about networking. Yeah, it was basically making the connection from pulling the data from the sensor and putting it somewhere. And then the second part, it looks like it's now trying to make trying to basically make something from that data. Is that a high level synopsis?
Yeah,
is that accurate?
That's a very good takeaway from it.
Okay.
And I go through all that because if you get on Google and you do a search for IoT platform, one of the things that's a little annoying to us, of course, as a smaller company, is that you're going to see big IT vendors that are claiming that they have a IoT platform. But what they're really talking about is they want to sell you these 9 components that they already have on the shelf. They're not integrated. They're already there. And for certain, if you're trying to solve a spot problem in that complicated scenario we just described, those are probably decent products. But for example, Oracle has a whole product called a complex event processor. It's a product by itself that you buy, and it's non-trivial in price. So all of these things that I just described, most of them have typically been point products or solutions from different IT vendors.
Yeah. And you were also mentioning earlier that originally the platform came from the component manufacturers that were basically trying to bridge that OT-IT connection. And they had, and this is what, started the verticals, right? These silos where they had a platform, but it worked just with their technology. Is that similar to the IT vendors? They had something that just worked with their tech?
I will say with IT vendors, they're less concerned about the real mixed nature of devices and vendors that are out there on the device side of the house. So they're a little more neutral to it, just like we are. Whereas since the first generation of platforms were built around a specific device type, it's rare that those platforms can extend beyond that class or that family of products from that device vendor. In fact, later this year, depending on how things go, we actually may become the platform for a couple of the device vendors who already have their own platforms, and they just have gotten to a point where they can't either accommodate devices outside their company, which their customers require, or they just can't scale their platforms anymore. They're not built for thousands of customers. And huge amounts of data volume. So, yeah.
Yeah. So now describe for me then, you also hear of the IoT cloud, specifically instead of an IT cloud, the IoT cloud. And at a high level, it sounds very similar, at least to the networking component of it, but it also holds, the database and the analytics. So how would you compare and contrast an IoT cloud?
Well, could you be maybe a little more specific?
Okay, no. So sometimes when you look at cloud services, there are some cloud services that are specifically for IoT, and so these cloud services, basically, what's different about them between them and an IT cloud service is they've got the ingestion. So they have all the protocols, that we were talking about, so you can ingest them. And then they also have the APIs to connect up with databases, various databases, whether they're real-time databases, whether they're, data at rest databases, SQL, non-SQL, Hadoop, and all the rest of them. So I don't know. So again, this is just to sort of clarify, but a company can get an IoT cloud service, and I guess that would be part of them maybe building their own service. But what am I missing here? I mean,
yeah, no, I understand.
Just clarify a little bit on that.
Yeah, absolutely. So you're right. So to a certain extent, what is missing, say if you're going to go over to Amazon Web Services and maybe use Heroku with that, which is an application building platform, or if you were to go to Microsoft Azure or IBM's Bluemix, one of these development environments, what is missing is a device cloud, so to speak, that can communicate data in and out of that environment. So that's where you saw a few weeks ago Amazon acquire a company called Telemetry that just does device trafficking, basically device protocols, talks to device, messages with them, and then traffics data back and forth. So that's definitely one missing piece that a generic IT cloud would be missing. The other thing that people don't totally grasp about IoT that most public clouds are not equipped for out of the box is this is a world of time series data and transactional timestamps. So what that means is that you are going to talk to a machine and it might send you 1 million vibration readings throughout the day. Well, if you're going to store all that data, that's the equivalent of 1 million bank transactions at your local online bank. Now, if you go to PayPal or any financial system and go try to do a query and just look through the results of 1 million transactions, you'll notice they don't let you do it because it slows computing systems down incredibly, having to sift through that amount of data. And so that's the other piece that's really missing from a quote-unquote public cloud where you could just build anything is a scalable way of dealing with time-based data and attaching that to a thing. So you for example, in your ideal world, would want to model something like a machine and then attach 1 million transactional records to it. So it's a really big data scaling problem. Having 1 million records is not a terribly difficult thing to do in the modern web these days. But when people think of records, they think of something like like dropping an order online. Like that's a record. You can certainly deal with those sorts of things at scale, but they kind of sit by themselves as opposed to being attached to something. So that's where this world starts to break down. Where a lot of what we're doing ourselves and other people are doing in IoT really is kind of pushing the boundaries of computer science even on the web side. The scale at which we're operating is really, really large.
Yeah, no, and we're going to have an episode specifically on IoT databases, but I think what you're referring to is basically the organization of the data, and having a time-based environment requires having a time-based database, and so there's different ways of doing that. Some are column-based versus row-based, and some are more tuned for real time. But okay, so you're saying the cloud. So long term, are you concerned about Amazon and their recent acquisition? Are they then going to be an IoT platform? Or I know they would seem like they'd have a lot of the networking parts of it, but maybe not the storage or the analytics. But what would be your thoughts on that?
I think they're certainly heading there. They're
to create a platform in particular, you think? Or?
Yeah, I believe that their outlook is that people can come in here and build generically anything they want to, and what they were missing was that device traffic and connectivity piece, so to speak. So I don't know if you'll see them start to add more IoT specific components in there, such as a time series database, maybe some lightweight business intelligence tool. I think it remains to be seen, and that's where this world right now is a little bit of the Wild West. It's a lot like 1997 in the web development world, where people weren't sure if they really needed application servers or web servers or some of the other infrastructure that was there. But then over time, you saw all those things fuse themselves into something called either Salesforce.com or WordPress.com, where it was kind of all there as a service. Right. And so everyone's going to have their different approach to it. Whether there's going to be collections of tools that are good for people who want to build and will always want to build, and then there'll be other tools where everything's fused together in a simpler experience.
Okay, so in the simpler experience, in particular in your simpler experience, what about the cloud? So then you provide storage, you provide what else? I mean, computation, I guess, with the cloud, storage with the cloud. Is that included as part of the platform?
With our platform, yes. We include data storage, two types. One that's kind of operational and real time, and another one's a big data store, a Hadoop type cluster, if you will, that you can tap into with other systems. We're providing, in our core of our system, we really it's a front end to almost the entire Java programming language, except we've made it simple to manipulate. It's kind of a spreadsheet-like experience. So when we talk about analytics, that's what we mean, is you can build any kind of processing routine, as it were, for anything. And then we have a way for people to build essentially data tables without being database developers. And so it's basically clicking around and building your own database tables, and then what normally would be hard-coded software code, you basically build logic statements and trees that can go through and sift through the data in real time or historically. And then you can essentially build reports on top of the data without having to be a web page developer. And so that's what we consider, of course, we're biased, a more modern platform, is that we're trying to really just deliver the application that's doing the real time, and I'd say like near term historical analysis of the data, like within the last year. We're trying to deliver all of that as essentially almost a commodity service. So the idea of creating web applications from scratch is becoming more and more passé. And it's more of a Silicon Valley thing, but there's just plenty of platforms out there where you can assemble web applications really, really quick. And our whole view is that the modeling the asset, connecting it, and even managing some of the workflows around it, like people managing, how a machine gets replenished and what technicians are allowed to work on it and things like that. That's just all a commodity. What you're really trying to do is put an application together to enable the data science. Okay. Well,
and so someone's listening, our listeners are listening here and they go, all right, I'm going to build a platform for my product. What I'm still trying to get my arms around this nebulous, this nebulous thing. Maybe another way to ask the question is, what's not included? So the backhaul, I think, I can't remember if you mentioned that was included or not, but we're obviously going to need a backhaul connection. We've got the connectivity. We're pulling data. Obviously, the hardware is not included, or I won't say obviously, but I don't think from what you've said the hardware is included. The backhaul is not included. What else is not included? Maybe that's another way of kind of trying to feel our way in the dark of what this elephant looks like.
Yeah, so that's a great way to approach it. So you've already hit the two big ones. You need a device of some sort, or a little computer that you can put into a machine. People tend to call those modules. And so you need a device that can talk to a machine that already is generating data, or you need to install a computer into a machine. So that's not included.
Because you're talking to the gateway, then is that right? You end at the gateway. You're not going all the way to the end nodes then.
Right.
Is that what you're trying to say? Or
usually if the end node is a computer with its own
I'm thinking sensor.
Yeah.
I'm thinking about the end node to the sensor. You're not going all the way to the sensor. You're going to some gateway or computer or module. Is that what you're referring to?
That's right. Yeah. So the end sensor, say a temperature sensor, will be plugged into some way into some sort of CPU, like a computer chip somewhere. And then that might be in turn have its own communications capability with an Ethernet port, or that may need to be wired into what's called a gateway, something that knows how to take information off a computer and then get it into an internet format.
So you're not doing any of that OT stuff. You're basically where IT begins. That's kind of the edge of your platform or a platform.
That is typically the edge of the platform. Now, here again is where we're in a little bit of Wild West days. There are IoT platforms out there that include a device that you can slot into your machine.
And these are from device manufacturers, or are they independent of device manufacturers?
They are now device manufacturers with clouds attached to them, but they're more meant to be embedded devices as opposed to devices that attach to the outside of some asset.
Okay, so the platform you're referring to now is one, or a class of platforms are from these device manufacturers. Is that right?
That's right.
Okay, all right, yeah. So then we get into the issue of the issues that we talked about before of being silos and being, I guess, restricted to a certain extent on the types of components that you can use.
Right, and let me clarify. So traditionally, when I was talking about the device manufacturer before, we were talking about devices that would be retrofitted onto assets.
Oh, okay.
And now we're talking and those would come from companies like, if you want to take a look, digi.com or Calamp, CALAMP.com, or Sierra Wireless. Now what I'm talking about is there are startups, particularly here in Silicon Valley. I'll just name a couple just to give everybody some grounding.
Yeah.
One's called Electric Imp. Yep. There's another one called Ayla Networks, AYLA Networks. There's a third one out of Minneapolis, although they just moved to San Francisco, called Spark.io.
Yes.
And they all provide a hardware component that you can slot into your machine. And so you would standardize your dishwasher or your smart refrigerator or your piece of production equipment on that machine, and you slot their hardware in, and then they take care of essentially running firmware on the machine that gathers data, and then they take care of the connection. And then in some cases they are starting to they either do the traffic cop thing where they'll send the data off to your other systems, or they'll provide that data storage later. So they're sort of clouding the boundaries of what an IoT platform is.
Yeah. As opposed to getting an embedded chip, and again, we're not talking about retrofitting, but getting an embedded chipset and then dealing with that API directly to go to the gateway. And that might be done by the device manufacturer, or again, device being the end node manufacturer or not. But you're saying here they're kind of reaching right into it with a module that can be embedded, as opposed to having to go straight to the bare metal.
Yep. And so by standardizing on one of those, three approaches, you give up a little bit of future flexibility, but you've taken care of a pretty big problem, which is how do I get data off this device? To that point, the other thing that's traditionally missing that you have to get in addition to the physical device and the connectivity is somebody has to write a routine, some small piece of code, 50 to 100 lines, that is going to sit on a machine or a device, gather the data, in some cases even do a little bit of data crunching,
like fog computing.
Yeah, fog computing is one term that's come up recently.
That's a little bit of fog computing with just a 50 to 100 lines of content. Yeah. It could be bigger, I suppose.
Yeah,
sure.
And there's you can keep going with that concept. I mean, you can have devices talking to each other and trading the load of what they're doing at the fog level.
Analyzing it and the data. Okay.
But if we get stuck on IoT platform for 30 minutes, you can spend about an hour on fog computing.
Yeah, I know.
But so, and that's where this is, again, it's a real wild.
Okay, but Bryan, you're saying there's another missing component is, sorry, I interrupted you in that though, but there's a missing component of these 50 to 100 lines of code that are doing what?
They're gathering data on the machine or device, and then they're sending it off. They might that piece of code might say, every time you see these 5 things happen, post this information back to the cloud.
And you're talking to it through your platform with an application, with an application protocol, or what mechanism?
Yeah, in our environment, we put something on the cloud side that we call a device adapter, and it deals with the protocol of talking to a device back and forth. And then within it, it has essentially a way of whatever the data format is, whether it's binary or text or whatever somebody's sending, it knows how to parse through that and discover what the information is inside.
So it can go really low level. It can go all the way down to text or binary, or I guess it could be a little bit more abstracted as well, and you could talk to it in a higher level kind of way too.
Exactly. And so therefore, what SeeControl is missing is that we don't do what we call an agent. There are a few IoT platforms that offer either out-of-the-box device SDKs or firmware that you can push down to a device, or they have this thing called an agent, which you can almost think of it as a robot that leaves the cloud. It goes out to a remote machine, gathers data, and comes back. And so we don't do that because we feel that, well, A, that's very complicated to manage at any scale. And then B, most of the device companies that are coming onto the scenes with a variety of different technologies in the next 18 to 36 months where out of the box, most machines are going to have SDKs or other sorts of little settings in them where it just says, where do you want to post this data in the cloud? And so we're equipped for that world versus the traditional world, which is very systems integration driven, where in addition to the device and the connectivity, the third thing you have to buy is somebody to help you write that firmware.
And that's what you're talking about now. The firmware you're referring to is the agent?
Yes, an agent, firmware, remote code, fog computing. Those four things are all kind of in the same bucket of I have to do something or put something down on the machine or device.
So that's more or less the glue then that'll glue that last. Well, it's gluing the connection between the operational technology and the information technology.
Yeah.
Is that right?
That's correct.
Yeah, and I guess there's pros and cons of going that way. I mean, your approach is more open so that your platform or platforms like yours could basically talk with any number of different types of devices. Whereas if you're getting this agent, then unless it's an infinite agent, which is very unlikely, then the agent's going to be targeting a certain class or from a certain manufacturer, and that might be good too, which is a little different than what we were talking about with the modules. But it seems like there's almost, if you want to go wide open, then there's a little bit of glue that needs to be developed. However, if you don't mind being tied to a specific manufacturer, then you can do it in a couple different ways that you've mentioned here.
Yeah, and it just depends on what you're trying to do. I mean, if you're trying to do something relatively simple, and I'll just bring up a consumer example. So if I have a washing machine, there's really only going to be a couple things that the average consumer is going to want off that washing machine. So if I'm a washing machine manufacturer such as a Samsung or Whirlpool or Maytag or Kenmore, taking the risk of embedding, essentially the equivalent of an SD card slot in my machine, and just having something a really simple platform that can get the data off them probably makes a lot of sense. And in that world, then as the product manufacturer, you're really only concerned about really a standard, like, will this standard or will this technology survive, over the next 10 years? So you're essentially on that level, you're making the same sort of bet that you would be making in whether or not to design an SD card into your laptop or PC. That was a debate at some point. So for certain simple scenarios, I think going with something that has already a device built into it, or comes like the device gets slotted into your product in a standard sort of way, it might make a lot of sense. And in our world, by the way, we can talk to all those existing sort of platforms as well through our API. So we actually embrace that in a lot of cases, because then we're not having to have a customer walk through the complexity that does sometimes come with talking to their remote device.
But then clarify that though. So there's the glue that you were saying that needed to be written that performed as an agent. Are you saying, though, that you can bypass the glue with your APIs, or you're still going to require that glue on the other end?
Yeah, if you have if your system can post directly using web protocols, what are known as web services, over the web. They can just post data right into our system right from that type of computer. Or if you already have another platform, a lot of platforms we've actually other platforms we've pre-integrated with, or you can just take the data from their API and push it into our API. So we would treat another computer system, so to speak, as yet just another device.
Okay. So I think I'm understanding it a little bit better now. So what you're saying is, if the device supports a higher level representation or abstraction of the data through the form of maybe one of these web interfaces or a higher level application protocol interface or application protocol, then you can support it. However, if it's really bare metal, you're dealing directly with bits, there has to be something that's going to transform those bits into something that the platform can understand. Am I getting it there?
Yeah, absolutely. You're right on target.
Okay, good. Well, okay, then I think that really clarifies things. All right, so hardware notwithstanding modules, backhaul connectivity, agent notwithstanding higher level protocols and APIs. What else is missing if someone buys, rents, or leases a IoT platform? What else do they need to buy, and then what else do they? I guess what else is needed?
Well, ideally, there should be somebody who's done this before that can walk you through the process. And there are folks out there that come out of the machine-to-machine world. Now, I'm speaking mainly in the business-to-business world, in industrial types of settings. But there's a class of folks out there, machine-to-machine systems integrators. They're not really big organizations. They're not PwC-type companies or Accenture-sized companies, but smaller ones that know how to pull together all three pieces: the device, the network, and the application, so to speak. Okay. And really kind of get it, out and running at a predefined, time, whatever your milestone may be. So that would be the one thing that I think is missing, because as we've sort of walked through this journey, even on this call, I'm sure all of your listeners can understand that what we're really talking about here is that this is still a systems integration world. There are some simple things that can be done out there, but most of the interesting things that you can do with IoT require a little bit of thought, a little bit of planning, a little bit of work. And it's good to have somebody walk you through that process. Now, we don't really offer that kind of service ourselves, but we have a network of folks that we trust and know how to walk through that process that we can turn folks onto. I think that's a big missing piece. I think maybe in 2 to 3 years that starts to dissipate or go away a little bit as device manufacturers get better at making their modules, their gateways, all these things we've been talking about, turning them more into like what you see with smartphones.
Communication ready. Yep. Yeah. Okay.
With smartphones today, where you've got something that just abstracts all the complexity of the hardware away and just lets you develop and click and put something together really, really quickly. But the reality is that today, and particularly on the industrial side, it is a little bit of a systems integration project. The good news is that historically, actually, Exita in our market has done a couple studies. Historically, most IoT or M2M projects, because of all this complexity we've been walking through, have been 2 to 3 year endeavors with an 80% failure rate. And
really?
Yeah, now that number has gotten into, I would say, typically year-long projects before people are ready to launch something at scale. And the failure rate's much lower. It's just anecdotal for us, but I can just tell that there are more folks that are making it through the process, so to speak, than there used to be.
So less glue having to be developed?
Yeah.
Is that what you'd relate the failure rate to?
Yeah, less new stuff. I think the other thing, too, is that devices and connectivity, which are the two big missing pieces that you need in addition to a platform, are much more inexpensive than they used to be. Some of the retrofit devices that are out in the marketplace, as recently as 2 to 3 years ago, cost $500 to $600 per a piece.
Yeah, that's crazy.
Or a cellular module was an $80 unit. to put cellular connectivity into your product. Notwithstanding the fact that you had to put a computer in there as well that might run anywhere from $20 to $50. So,
and you had to pay for that connectivity on a monthly basis.
Yeah, so if you were a pioneer and an early adopter and trying to do anything here, you're really going to see about 90% of your budget traditionally get eaten up by both devices, and then if you do go cellular, which a lot of people do, I'd say well over half, you're going to end up with that cell plan. And so if you don't string that all together right from the first day, your odds of success are going lower every month that goes by. And basically your whole budget gets eaten by the device and the connectivity. Well, now, thanks to both Moore's Law and Metcalfe's Law, where essentially computing prices and networking prices are dropping every 18 months in half, we're in a world now where it's not quite throwaway, but you're allowed to make a lot of mistakes with both the devices and even the connection costs. And so there's more resources for people to kind of get through the journey. Plus the journey is simpler. And so it's and that's why everyone's excited about IoT right now. Everything's converging to a point where it's not the easiest thing to do in the world, but man, it's gotten a lot simpler than it was in 2012, 2013. And in 2012 and 13, if you were trying to do this in 2008 or 9, it was really difficult and really expensive. So that's where all the excitement comes from. But
it's not as difficult and not as expensive. That's exciting.
Yeah. And that's like a lot of big innovations. Everything, 4 or 5 things converge at the right point in time and space, and you have explosion of innovation, creativity, and new ways of doing things. And we're on the precipice of that, right now.
Yeah, no, I dig it. So to circle back on the platform, other than devices and connectivity, and maybe some glue, which might require some help from these machine-to-machine integrators, you have pretty much everything? Is that what you're saying?
Yeah, those are the things that are missing.
Okay, so just devices, to be clear, we're talking about sensors and everything that needs to support the sensor to send the data. For connectivity, we're talking about it could be cellular, it could be a number of other, I guess it could be cellular, or it could be hard-lined. If that's the case, there's obviously the low-power, ultra low-band stuff that's coming out now, as well as potentially satellite, which I think are trying to compete. But that's what you mean by connectivity. And then machine-to-machine integration, that was the glue that we were talking about for the agent, which is a critical part. Can you do a shout-out to a couple example companies that do this machine-to-machine integration?
Yeah, one great one that we work with, and I think you've even met them before, is Logic PD.
Yeah, they're on the program. Really good.
Yeah, about a 500-person strong company. They've been helping people design smart products since what feels like the dawn of time, going back into the 60s, working with telemetry, pre-internet telemetry with machines and devices, and they helped design smart thermostats long before Nest. And they've done things like in the NFL, like a lot of the smart helmets in the NFL were designed by them. So that's a great group. That's cool. And then I'll just kind of focus on each coast. And we're North American centric in a lot of ways, but on the East Coast, we work with a great firm called ClearConnects. That's done a lot of these projects end to end. And then on the West Coast, we worked with a firm out of San Diego called DCS. So those are our 3 sort of go-to integrators. There are others that we work with, but just in terms of a national organization and then one for each coast, those are our 3 primary partners. And then we have independent consultants. There's a lot of sort of ex-Siemens, ex-General Electric, types of people who are electrical engineers that are freelance contractors that are out there doing lots of M2M projects.
Oh, really? Okay.
And really large ones, like you'll see like a 1 or 2 person group, so to speak, out there doing somebody's entire revenue-driven telemetry program for a Fortune 1000 company. So we know some of those folks that can help walk people through pieces of this journey, or also bring it all together for them. Okay. And I don't want anyone to get mistaken. The systems integration piece of this it's actually not that involved as long as you know what you're doing. The work content isn't that heavy. Because again, if you're talking about a device, it's a couple hundred lines of code, and then just making sure the components you pick all talk to each other. So they can be really, quick projects, not multi-year long engagements.
No, but I think what you're doing is you're also talking about the power of a platform, because if you weren't using a platform and you were to roll it yourself, then the system integrator comes in. The glue has to be developed in a number of different places beyond just that OT IT connection. System integrating with the databases, system integrating with the cloud, system integrating with the analytics, system integrating with your business systems, the back end business system integrating with multiple products being connected together. But I think that's one of the big benefits that our listeners should take into account here is you can minimize what you're doing effectively is minimizing, and maybe this is an obvious statement, but you're minimizing your system integration dependency by using a platform. There's still going to be a little bit, potentially still a little bit, depending if you want to go wide open or if you want to go very specific, as you were saying, you have a very specific use case that's relatively simple. You maybe don't care about having diversity in choices for the electronics components. But that's what we're talking about here is, because I mean, that's when people do hear IoT, it's almost synonymous with system integration. So platform IoT, it's just a little bit of system integration is what you're saying, 50 to maybe a couple hundred lines of code.
That's right. That's in most cases, I would say it's gotten down to that point. And the trick is not to, as much as we've gone into a lot of detail during this discussion, it's just not to overcomplicate it. It's just pick something and go. Really, even if it does lock you into something for a while, because there's nothing that's more valuable than learning.
Yes.
And we do see a lot of companies. We have we do have some consumer product type of companies that are in our platform. It's not our core sweet spot type of customer, but they are attracted to our platform. And a lot of these companies are startup type companies with just to over stereotype them, a couple MIT engineers, and they'll get analysis paralysis on what system on a chip they should put into their smart product, or even the connectivity option. I have a couple of them that they can't. It's been 18 months and they haven't been able to make a decision. and had they just gone ahead and done like something like an electric imp or a Spark.io, they would have locked themselves in, but it could have saved them a lot of time. At least they would have learned something by this point, and been able to sell a couple smart products to a customer. So, and
I think Bryan, you brought up, it was interesting because I remember one of the quotes when we did an interview at the GoGoNet Live conference. You were saying, and you're going to have to clarify it, but I think you said something like 80% of IoT projects change 2 or 3 times, and just during this stage that we're talking about, this this inception stage. Can you talk to that a little bit more? What were the actual numbers? Because I think that's very illustrative to what you're saying. The point. Now, I'll always argue that yes, get on with it. Start experimenting technically, but I really believe that you need to plan this from a business point of view in advance, before you start doing that, because you need to know, what exactly you're experimenting with. But what was that statistic? Because you've been in the trenches on this. It seems like it changes so much that, like you said, just go for something and you maybe you'll just throw it all away and start again anyway. But you've learned a lot.
Yeah, absolutely. Our numbers show that about 80% of projects is the number where things change. Now, we're a little skewed on that because our platform is essentially designed for iteration and on the fly change. Yeah. We're really encouraging people to innovate and go. And if your first thing doesn't work, try something different or extend what you started with. But I think if you talk to people broadly, almost every project changes, and the reason why is because most things that are truly compelling in IoT are revenue driven, which means that there's a new customer on the other end. And so that customer comes in one of two flavors. It's typically, in our experience, been if we're working with a product company, their top 1 to 3 customer will come in and say, I'm simply not going to buy any more products from you unless they're intelligent and they're online. And that will drive a furious set of activity to kind of get that product smart and online, specifically for that customer. Well, that customer may have a whole bunch of reasons why they want it online that differ from what the other 90% of the customers would want to see in an online service attached to that product. And so that's where a lot of that change comes from, is that you do something on a point basis for one or two or three voices out in the market versus the whole market itself. And so in that regard, almost all IoT projects are essentially market research projects. And your solution, gets in the hands of users, and they tell you that you thought feature A and B were the most important, like a couple analytic charts or graphs, or maybe turning a machine on or off. But it turns out that the whole value of the service was in features you didn't even account for. The somewhat classic example of this was OnStar, which is still probably the biggest IoT service out there. Started in the late 90s. And the initial technology infrastructure was all designed around the idea of concierge services. So GM thought that the primary reason that people would ever pay for the service would be to order a pizza on their way home from work. Well, it turns out the only reason people subscribed after the first initial free year was to unlock their doors over the satellite network. And the infrastructure wasn't designed to scale that way. And so they had to kind of go back and change it.
Oh, really?
Yeah,
okay.
And that was a pretty expensive change and extension. And that example just applies all over the place. Getting back to a couple of the consumer products guys I just mentioned, I mean, one of them is a coffee company makes a smart coffee maker, and one massive chain that runs coffee shops wanted the system to essentially be able to let people upload their recipes and then brew cups at scale. But then most of the other customers just wanted what they call a fleet management solution, something to tell them for their 200 stores how many brewers they had, whether they were on or off, and which ones needed to be returned. Simple. Yeah, so those are two potentially different services, or the same service if designed holistically from the get-go.
Yeah, no, that I think that's a real important point, and it comes into the flexibility of your solution then. So that's probably, although we're not really getting into, what to look for when you're buying an IoT platform, but I would put pretty high on the top of the list, the ability to iterate easily and be able to, try different things. Okay, well, Bryan, I think we've come to the end of our time. This has been real useful. I mean, I think, it just coming up with this definition, I think people will walk away with a lot more, understanding of IoT, just by understanding what exactly is an IoT platform. And the way that it's evolving right now, it's really exciting because it's basically covering everything except for what makes sense. You're not going to cover, I suppose you could include a backhaul in an IoT platform, I suppose, if you could figure out align the business models correctly. But you're certainly not going to be able to include all the different hardware choices. I think there's like 1 million different sensors. I don't know how many connected sensors are out there, but that makes a lot of sense. So this is a great approach, and I guess there are pros and cons to it, but unless you're doing something really far out there and you have the expertise, I'm just trying to, maybe you can leave us with this thought, but I'm just trying to see when would it make sense not to use a platform as and do it yourself. What are the cases, Bryan? We'll leave it with that.
Yeah, the big one we've seen is that for us, as a sort of third-party, neutral, technology-agnostic platform, is that there's a lot at stake here. So if you're a company where smart products really are going to impact your future, now I think they're going to impact everybody's futures, but there's some companies out there like industrial conglomerates and other kind of companies like that where all their products were going to be connected, or 90% of them at some point. In that case, if it's really strategic to you, if I were running those companies, it's difficult to give up the infrastructure, anything about a smart product to an outside party. So if you really commit to it, you can make it a core competency and move forward. And that's, of course, the one scenario where I think it makes no sense to do anything with an IoT platform except just use an experimentation tool. And we have customers that do that. We have a couple of big industrial conglomerate type of companies that use us solely as a prototyping tool. And then once they perfect their service, they go build something from scratch. But you need if you're going to do that, you need to be really committed to it over the long haul. the converse of that is that we've had customers who do make products, found themselves after 7 or 8 years of running this type of service as operating like a software company or having to think like a software company and realizing like that they never want to be a software company. And so that's the other, part of this is that this whole journey will confront people with a decision at some point of whether or not you want to be in the software business or the hardware business. And it's very difficult to do both. Unless you're Apple. Apple's done a very good job of it. Google's done a pretty decent job of it. There's others, but it's a difficult, proposition. But if smart connected virtualized products are critical to your business strategy and future, that would be the one example not to use an IoT platform. And the other reason not to use one would be if your deployment is sufficiently small, say under 1,000 devices out there, that also might make sense to build something up with relatively simpler technologies, like the .NET programming language or Ruby on Rails type of programming languages, which is very popular in Silicon Valley right now. Lighter weight approaches. So if you're not worried about scale, then you might think about owning it as well.
Yeah. Well, I mean, I would argue in both cases, in the case of the critical from a core competency point of view, that you might want to still use a platform for your version 1.0, because, the same arguments that you've used just from your data, and I know your platform, it appears like you can change it pretty rapidly, but yeah, 1.0, maybe use a platform, you learn a lot, and then you decide, you see what the core competency, an IoT product affects obviously more than just the engineering group. It affects the support group. It affects the operations group. It affects the whole company. So maybe you start with a platform. I would recommend that you would start with a platform, learn and see what the transformations are needed from a technology point of view and from a corporate point of view. And then if it makes sense, then develop yourself. At least you've got a lot of experience of how to do it. And in the smaller situation, I would argue again, maybe it's really small, but they could use a system like yours to prototype it, see how it works, and then the same thing. Then maybe engineer it if it doesn't make sense from a business point of view. I don't know. To me, I think we're at such an early point, and I don't even know if we're at the 1.0 yet of IoT productization that we'd, just say, let's just sort of, we know enough to build the whole thing. I don't know. Maybe that's a skewed way to look at it, but I would think that an IoT platform in all situations would be the right way to start.
Yeah, we certainly think so. I mean, there's if you have access to really low cost developers and almost free infrastructure, give it a try. But almost everything else economically is not going to sketch out to the same level of investment. And our plug would be we can get people started just on the device data collection side for $500 a month. I mean, typically
that's very cheap.
Yeah, I mean, I don't want to say that we're cheap, but it's affordable,
inexpensive,
and it's approachable, and you can scale up from there. But you can spend that amount of money with a developer in about 3 weeks.
500. I would think you could probably.
I'm sorry. I meant
in like less than 5 hours.
Yeah, I'm sorry. The annual cost of our service is the equivalent of a developer for a couple of weeks. So
yeah, for sure. Yeah. All right. Well, with that, Bryan, thanks a lot. That helped clarify a lot of things, specifically this middling agent in there. Can you maybe tell our listeners, I think they're going to want to hear about SeeControl, maybe tell them where they can find more about you and your company.
Yeah, absolutely. We can be found at www.SeeControl, SeeControl.com. And at our website, if you exchange your information with us, we will give you immediate access to a couple things. Primarily, we have a knowledge base of analyst reports and white papers that go over a lot of these topics that we've touched on today that people can get for free. And then, of course, there's videos you can access and other information, on our company. But that's a great place to start. And, of course, you can call us. Our phone number is 800-540-2850. And ask for me, and we'll be happy to chat with you.
Excellent. Well, I'll put all this in the show analysis notes. yeah, check it out. I think I didn't know about the analyst reports and all the information, so it sounds like I don't think I've signed up, so I'm probably going to take a look myself. All right. Well, thanks, Bryan. We'll talk to you soon.
Thank you, Bruce, and thanks everybody for listening.
Okay, that was an informative talk with Bryan Kester. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support the show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is Nailing the Amorphous IoT Platform to the Wall with Sean Lores of Zively. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be an evolved one.
You have been listening to the IoT Inc. Business Show.